Scatter plots by Badeau, Abbi Lee, and Abbi Noyes. There are two types of variables for scatter plots: explanatory and response. The explanatory variable explains the response variable, and that goes on the x-axis. The response variable shows the change as a result of the explanatory variable, and we put that on the y-axis. When asked to describe scatter plots, we use the acronym DOOFUS to help us remember what to say. D stands for direction. For direction, you look at the graph and see if it's going in a positive or negative direction. F is for form. Is the graph linear, curved, or have any other pattern? U is for unusual. Are there any concerning potential outliers or points of influence? S is for strength, which is how strong the relationship between x and y are. Here are some examples of the things that I just talked about: direction, form, strength, and unusual. For direction, you look at the graph and see if it's going in a positive or negative direction. For form, you can see that some of the graphs are more linear and gathered together. Other graphs are curved, which means no linear association. For strength, you can see that the first graph fits the linear form better than the next two. For unusual, you can see the two circled points of influence that could skew the mean or other statistics.
When we model a scatter plot with a line of best fit, we use the least square regression line as a model for that. The least square regression line is y hat equals a plus bx, where a is the y-intercept, which is the value of y when x is 0, where b is the slope, how much y increases when x increases by 1, y hat shows your predicted value for a certain x, and x is your explanatory variable. The correlation coefficient, labeled as r, is a decimal which shows us the strength and direction of the least square regression line. If the decimal is closer to 1, that it is a positive, strong relationship. If it is close to -1, it is a strong, negative relationship.
The coefficient of determination, r squared, is calculated by squaring r. A certain percentage of the variability of y hat is explained by the variation in x. Check the residual plot before to determine if you can even use r squared. It describes the association of the two variables.
If we determine that there are no noticeable patterns in the residual plot, that means that the LSRL is the best fit model for the data. We can use our LSRL to determine a specific predicted y hat value for a given x value. We don't know the true y, but we can make an educated guess. When using the LSRL, you have to be careful to not go too far beyond your x value intervals. The y hat you get as predicted value may be inaccurate. This is called extrapolation. We don't know if the LSRL works beyond our interval, so we can't predict it.
A residual can be found by subtracting the predicted y hat value you find from the observed y that actually is true. A residual plot shows all of the residuals for a specific LSRL you found. If there is no pattern in your residual plot, then your LSRL is correct and able to be used to make predictions. If not, you should look for another way to make predictions for your scatter plot.
There are many common mistakes when analyzing scatter plots. 3 common mistakes are: 1. Not checking residuals before assuming linearity. You have to check your residuals before you can use the LSRL. If the residual plot has any patterns whatsoever, including curves, lines, etc., you can't use the LSRL. 2. Confusing which variable is explanatory and which variable is response. The explanatory variable goes on the x-axis, and the response variable goes on the y. The explanatory variable explains the response variable. When making predictions, you cannot plug in a predicted y to get a predicted x. 3. Do not assume that correlation means causation. Instead, you can say that the variables are associated. Just because we predict something doesn't mean that it's an accurate y value.
This scatter plot shows the relationship between height and weight of 81 separate individuals. Describe the graph. The direction of this graph is positive. The form is approximately linear, and the strength is moderate. There are no concerning outliers or influential points. We are now given that the LSRL of the scatter plot is y hat equals negative 264.66 plus 6.1638x. Interpret the y-intercept and say whether or not it makes sense for the problem. Typically, a y-intercept tells us what the value of y is when x equals 0. But in this case, we know that a person cannot be negative 264 pounds. So it does not make sense for this problem. Use the LSRL to predict a weight for a person who is 70 inches tall. If we plug in an x value of 70, we conclude that a person who is 70 inches tall can weigh 166.8 pounds.